here they are. Boards are back from PCB Way. I ordered these on the 3rd and it's now the 8th, so that took just what, 5 days including shipment and all of that kind of thing. So let's see what we've got. Yeah, impatience. And there they are. So what did we get? 5 boards. Well, yeah, so far so good. And this time my V-score is present, so I'm pleased about that. So they should, and they do, break apart nice and cleanly. Well, looks like I've got some soldering to do. As before, I'm going to start with the components around the 5-volt regulator. I've buzzed it out and I haven't got any shorts between plus and minus 12 volts and ground, so that's good, and I'm quite pleased with the way that my improved thermal pad for the 7805 has turned out. So I'm going to flow that onto there. I'll probably use a hot air rework station to flow that on to make sure I got a really good thermal contact, but I'll be back when I've got some more things to show. Well, here they are. It took me several hours to get everything soldered using my dodgy soldering technique, but yeah, no particular problems. I decided to put all these 3 boards, the Pico and the 2 I/O boards, I decided to put them on sockets so that I could get them off and change them. That was particularly an issue with the first one, where they released the Pico 2 and I had to desolder a Pico from the board in order to test the Pico 2. But anyway, yeah, pretty pleased with how they all went together, and it's time to do some rudimentary testing. I've turned it on and nothing went bang, so it's time to put some signals through it. So I've plugged them in and turned them on, and if we turn the volume up, a lot seems to be working. So we're getting our clock output LED. The fact that I'm getting reverb, I'm getting multiple echoes, means that it's talking to the PS RAM memory. Okay, I can control wet dry mix, so yeah, so a lot seems to be working. So I've written some test harnesses, so I'm going to go through the hardware in detail and see where we're at. But yeah, already quite a lot seems to be working. I was getting some fairly horrendous bounces off my rotary switches, and so I've changed the routine, the function that polls the switches to find out what the current value is, so that it records every time the value returned from the switch changes. It records the time at which it's changed, and only if that value remains stable for more than what I've called debounce time, which I can change, but I've set to 200 milliseconds, only if it remains stable for 200 milliseconds or more does it trust it. and set the global variable that's used elsewhere in the code. These are the results in practice. I've just stuck some knobs on so that you can see me turn them, but as I turn them you can see 2, 3, 4, 5, 6, round to 7 and back again, and I'm not getting any substantial bounces, and in fact I think it's quite nice that I can turn a couple of positions, and because of that 200 millisecond debounce time, it skips over the intervening positions, and I think that's actually quite handy. I quite like that, and it doesn't matter that there's a 200 millisecond lag between me actually moving the switch and the global value being updated. I don't think that matters, because it's just a user interface. Having it poll the switches reliably is far more important, and these are the global ratio settings, similar kind of algorithm, and switching between them. So yeah, quite happy with that. So switches, tick. Testing the potentiometers. This is polling them just once a second. Obviously, in reality I would be polling them continuously, but rather than it scrolling up and down the page, I'm just polling them once a second. But this is the clock speed, variable from 40 up to 240. I could change those ranges, obviously. This is the feedback from 0 up to 1. So 1.00, so I'm getting a good 1 and a good 0, and any points in between. And this is the wet-dry balance, and that's going from 100% dry and 0 wet through to 1 wet and 0 dry. So yep, all my potentiometers working fine. Testing PS RAM, all completed correctly. So it's written 8 megabits in 0.9 of a second, and it's read 8 megabits in 1.6 seconds. So PS RAM's working. Rotary encoder, as before. Accurate changes of direction. If I go forwards, 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 or backwards, 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 it records those quite accurately. And then the switch, again, I've put my debounce, my software debounce routine on this. So if I press it, I get a 0. If I release it, I get a 1. And no bounces. So that works quite well. So no problems with the encoder. I wanted to see how much of a difference moving to a 7805 on this much better thermal ground plane had made. If you recall, on the first version of the Camberwell Parrot, I'd used an LM1117, which has the tab on the 5-volt output of the regulator, whereas on the 7805 it has the tab on the ground, and that let me put a much bigger thermal zone. So I thought I'd take some thermal images. These are the results. The revision 1 board, the regulator was running at 58.4 centigrade, whereas on the revision 2 board it's running at 42.9, and in both circumstances the board had been on for a good half an hour, audio running through it, that kind of thing. So it was a realistic test between the two. Interesting, the Pico itself is running at a slightly higher temperature, the Pico 2 compared to the Pico 1 on the original board. But yeah, I'm pretty pleased with that. It's made quite a big difference, and you can see the heat is kind of spreading out from the regulator around the board, whereas on the revision 1 board it's much more concentrated around the regulator itself. So yeah, pleased with that.